Hello guys, welcome to this system design tutorial series. So in this series we are going to discuss high level system design topics. So here I have listed some topics. If you feel you can also let me know through the comments, okay? Then I will add those topics as well. But as for my understanding, I have picked this topic to HLD system design. So first thing we'll see like what is system design, the introduction of system design. Then these are the topics I have picked. So what I'll do is after completion of each topic, we'll mark this list as a done, and at last we'll complete one project with all those topics which we covered. Like we'll implement all those things in our project end to end. I will show you from scratch like how to start writing the code as well, even through kind of low level system design concept. Then we'll complete the coding, then we'll try to scale our application, we'll try to cluster our db, scale our db as well. We'll use the polling concept, we'll use the rate limiting concept. Then we'll make our system as a fault tolerance as well. We'll enable the logging mechanism, caching, load balancer, proxies. We'll try to implement this cap theorems as well. Okay, so let's start with this system design intro part. What is system, why we are going to learn this system design concept? So like whenever you work on any application, those application you have to know like end to end concept, then you can design a very scalable, or you can say customizable system, right? So you need these concept not only in application server side, even database side. Let's say you work on DB side as well, so you need these concepts like scaling, clustering, sharding, replication, indexing, and how to migrate the DB and types of DB. This comes inside the part of data storage part. Okay, so without wasting time, let us start the system design intro. First, what is system? And this system design, if you break this sentence in two parts, system and design. So basically system is, you can say, a term, or you can say an architecture, like of software or technology that communicate with each other, to interact with each other to order to serve a certain set of clients or users, right? So system design, you can say, can be defined as a user of system as well, requirements of those clients or those user, you can say, and then components. These components or these topics, you can say, for now it's a components. Those components will pick based on our requirement. Okay, if we need some kind of caching mechanism to cache the data to make our application very faster, so we'll use caching. If we don't need caching, then we'll not use caching. So based on the requirement of the components, we'll integrate those components. Let's say if even for, let's discuss about types of DB as well. Okay, excuse me. Then we'll basically, based on requirement only, we'll choose which database we need to pick. And do I really need replication on this DB? Do I really need sharding, clustering? So just components are nothing but based on requirements you will pick. Okay, so designing is nothing but you should have good understanding of all these topics, and then along these topics you have to implement this concept inside your development or designing of an application. These are called system design concepts. Okay, so the first concept I have taken here, client server protocol. So this intro part is done. So we'll mark it as a done. In client server protocols, what is client, what is server? So we'll try to understand this. Let me open the whiteboard here. In client server architecture, this is the very basic things in your system design topic. Client and server. What is client? Client, you can say any user that sits here. It's any user. Okay, and then server is some kind of powerful system. Just understand, server is some kind of powerful system. If you try to relate in real time example, imagine like you visited a restaurant. So you are the client, user is client. Okay, and client, one who orders the food. Okay, and the waiter is here a server. that takes your order and bring it to you. Okay, so client is like a person who wants to do something on their computer or device, you can say. So let's say this is our client. So client make a request to server, hey, I need this resource, I need this file, I need this movie and all. So client make a request, then server process those requests and send a response back to client. Okay, so this is our server, this is our client. Clear? So if you take that typical example of restaurant side, I mean client is like a person who wants to do something on their computer or device, okay, like accessing a website or using an application. And server here is a waiter. uh, it's like a powerful computer that stores and manages the information or resources you need. Okay, basically it receive a request and send back the requested information to client. Clear? Think about the email system. Email, when you open the Gmail box like this, you clicked on the inbox, right? You click on inbox, you will get all the inbox, you will mail inside inbox like this list. So mail here, your Gmail interface is a client. Gmail interface is a client, and once you request the inbox mail, spam mail, important mails, you are making a request to email server. You are making a request to email server. An email server is a powerful computer where uh, it processes those requests and send back response to you. I mean, then you will able to see those emails as an inbox, as in spam, as important things, right? So this is called client server architecture. Clear? So client server means one client will be there, either it will be user, devices, anything which make a request to server to get something, then server will process those requests and send back to the client. Clear? Now, the example which I've taken is email server. That's also like a client server model. But client server model can vary based on your architecture, based on your requirement. What I mean, let's say here we have one client and one we have one server. Okay, this is kind of client server architecture. This is called one tier architecture, two tier architecture. Two tier means why? We have one tier is client and one is server. So in this case, client will make a request and server will process those requests and send back to the client. Okay, this is called one two tier architecture. Here basically involvement of two components are there, two systems. One is client system, one is server system. Similarly, we have different types of you can say architecture. Three tier architecture. In three tier architecture means one you will have one client, will have one server, and then one you will have one DB. Okay, so client will make a request to server for server to send response back to client. Server will process those requests and server will communicate to DB. Server will communicate to DB, then DB database will send response back to server, then server send will back response to the client. So this is called three tier architecture: client, server, and DB. Three entity will play role here. One is client, one is server, one is DB. Okay, similarly like three tier we have n tier architecture. Based, I told you, like based on the requirement you can design your tier based architecture. Now in n tier architecture what will happen? There are n entities or n involvement of n system. N system means will sometimes we need the client as well. Let's say we'll have client, then we'll have server. Okay, then we'll have the DB. In between server or client, if I need to set some one system that will interact with server behalf of you, so we'll set here proxy server. So this is also a system. This is called n tier. One tier, second, three, let's say four, and in between server and DB if you need some caching also. This is also a system, right? So this is kind of four here, then fifth here. This is entire architecture. That's I told you. Architecture totally depends on your requirement. Means how you are going to design your system. Those concepts will see like what is caching here, what is proxy server, and all. Then you can design your system as a scalable system. Okay, so we'll see those things. This is all about your tire. Now, if you're going to design a client, so client will also some types and server will also have some types, right? So client can be categorized in two types. Client you can categorize in two types. One is called thin client and one is called thick client. Even server also, if you develop the server or design a server also you can categorize in application server. Multiple servers we have: application server, uh, wave server, database server, right? So these are called types of server concept. Now, what is thin client? We'll discuss about thin client and thick client. What is thin client? So thin client means the system which we are going to design, I mean, as a client, let's say, as a client to be specifically small, and bulk of data processing occurs on the server. Means the main logic things and processing will happen on the server side. Let's say you are going to design a system in such a way that all the processing or complex thing happen on server side. Okay, here you will have the client. So this is example of thin client. Means majority of process you are doing inside the server. So this is server will be I mean fatty here, but client will be thin. Example like e-commerce application, the processing you I mean all the large processing you will do inside the server, okay, not inside the client. So this is example of thin client. Okay, thin client. Even let's say streaming application, all those things happen on the server. You just need one UI that will get the movies and it will just start playing. So processing will happen on the server side, less processing inside your client. This is called thin client. Okay, so bulk of data processing mostly occurs on the server side. That comes in category of thin client. Clear? Now thick client. What is thick client is a thick client, it's called fat client. The fat client means all the bulk kind of processing, bulk processing will happen inside the client. I mean, just like example is video editing software. So once you get the UI of video editing software, you will I mean edit your video and all. Everything will happen inside the clients only, inside the client application. So this is called thick client. Let's say video editing software, some kind of you can assume like game. Okay, these are example of thick client. Clear? So what we covered today, like we see like what are the architecture here. One is called client server. In client server again we categorize one tier, two tier, three tier, and tier. Okay, basically in one tier is a simplest one, equivalent to running the application on the personal computer. That's it. This is called one tier architecture. Second tier means two tier means here involvement of client and server will be there. So client make a request and server will process those requests and send response back to client. Now there is third type of client, a third tier architecture also. Here we'll have, I explained you, like one is client, then server, then DB server as well. In n-tier, it totally depends on your requirement. If you need caching, you can add extra tier cache. If you need proxy, you can add extra layer of proxy as well. So those are called n-tier architecture. Basically, n-tier um, mostly this concept involved in distributed system design. Distributed system means when you develop a system at a distributed level, here, kind of. This is called n-tier, and you will communicate through this system. Okay, that's called distributed system model. Clear? So that's all about it in today client server architecture. If you have any question, please raise a comments here, and if you need any extra topic to be in added here, please write a comments. And but make sure, like, please like and subscribe this channel, then it will keep me motivated to complete all these topics along with the project. Important part of this tutorial series is we'll see live project with all these topics. It's kind of one capstone project, we'll say, uh, with all these topics we implement once we complete all these topics and during this course. Okay, so that's it for today. Please like and subscribe this channel. Thank you.